This says notes 5.3 to 5.5, so we're doing kind of skimming the surface over those next sections. Before we begin this, I want to make sure that you understand solving inequalities. If you have to solve an inequality, it's just like solving an equation. Then if you add like c to one side or 10 or whatever, you have to do the same thing to the other side. So all this is stating is that everything with solving inequalities works exactly the same as solving for equations, except that if you divide by a negative, then you have to flip the sign. Alright, so now we're going to look at exterior angle inequality. So for this one you have to know which one is the exterior. This is 1, that's the exterior. And which angles are the remote interior. So remote interior, there are 3 angles interior. This one is adjacent to angle 1. So that one is adjacent. Remote means far away. So this angle and this angle, those are remote. And they're interior. Okay, and it turns out that the measure of an exterior angle of a triangle is always greater than the measure of either of its corresponding remote interior angles. So angle 1, the exterior angle, is bigger than angle A. Angle 1 is also bigger than angle B. So you're going to get a picture like this, and you have to say, okay, list all angles whose measure is less than the measure of angle 4. Well, angle 4 is an exterior angle. And it's exterior to several triangles in this picture. There's the picture, or the triangle that looks like this. You've got a 4 here, a 2, and a 5 right there. 4 is also exterior to this big triangle right here. So it's exterior to the angle that's 8 plus 2, both of those together, right there. And then it's bigger than 7. So angle 4 is bigger, or the angles that are smaller than angle 4 are angle 7, angle 8, angle 2, and angle 5. And then it says list all angles whose measure is greater than the measure of angle 8. So here's 8 right here. We want all the ones that are greater than the measure of angle 8. So what we're going to do is we're going to find all the exterior angles. So if 8 is a remote interior angle, it's a remote interior angle for this triangle right here. Okay, so we've got several pictures going on here. Let's pull those off to the side. So you've got angle 9 as an exterior angle. You just find all the exteriors. 9 goes with 8 and 6. Okay, and then another part of angle 8, another triangle with an exterior angle where 8 is a remote interior is the exterior angle 5. And then of course you've got this one where angle 4 is the exterior, and then 8 plus 2 is right here, and then 7 is right here. So in this picture we've looked at this is an exterior angle, this is an exterior angle, this is an exterior angle. 1 is an exterior angle, but 1 and 8 are adjacent to each other, so those don't count. So we have 3 exterior angles whose measure is greater than the measure of angle 8. In other words, it's the remote interior angle. What exterior angles are there for the same triangle that 8 is related to? So this would be angle 4, angle 5, angle 9. Alright, the next thing about this lesson is if one side of a triangle is longer than another side, then the angle that corresponds to that one is also longer than the other one. So 7 is all the way across this. If I go all the way from 7 across the triangle to the angle that's exactly opposite of it, that would be angle X. Angle X has to be smaller than angle Z because angle Z has 9 across from it. So big side, big angle, small side, small angle. And then the next one says if one angle of a triangle has a greater measure than another, then the side opposite the greater angle. So these just go both ways. They mean the same thing pretty much, but in this one we're looking at the sides, tell us where the big angles are, and this one is the angles, tell us where the big sides are. So if we list the sides of a triangle ABC in order from shortest to longest, this is the small side, small angle, so this has to be the smallest side. This is the medium angle, so this has to be the medium side. This is the biggest angle, so this has to be the biggest side. So, but pay attention to shortest to longest, because sometimes those will be longest to shortest. But in this case, it's smallest to longest. So this will be AC, and you have to put the line segment over the top. Smallest, and then AB is the medium, and then BC is the biggest. So this is the longest, this is the shortest, AB is in between. List the angles in order from least to greatest. Now this one doesn't have M either, but it gives us a perimeter. So 8 plus 11 is 19. The perimeter is 28. So 28 minus 19 is going to be 99. Good thing I'm a math teacher. Oops, erase. Okay, so this is 9. So this side equals 9. So then now we can go and make these, figure the angles. So we're going from least to greatest. So 8 is across from angle E. So angle E is the smallest angle because 8 is the smallest. L is across from L is across from side ME. So angle L is the next size, and then M is across from the biggest side, 11, so the greatest one is angle M. But again, pay attention to the statement. Sometimes it'll say greatest to least. All right, Tonia's following kite directions. She needs to make a congruent triangle with the triangle pieces. The directions say to begin sewing the two pieces of fabric together at their smallest angle. But you also have to pay attention that you're going to sew together the longest side. So if I look at triangle ABC, then this is the longest side and this is the longest side. So now we have to decide, because it says to begin sewing the two pieces together at their smallest angles. So we've got to find the smallest angles for the triangle on the left. It's across from the 1.5, so that would be angle A. And then on the other one, 1.5 again is the smallest one. That goes with D. So she's going to begin sewing angle A to angle D. Now we got one like this where we have to list the sides of triangle ABC in order from least to greatest. And all they give us are these expressions. So you think, what do I know about the angles of a triangle? Well, sometimes they can be perpendicular, sometimes they can be 180, sometimes they can be other measures, but they didn't tell us anything different except that they gave us the three sides of a triangle. So the three sides of a triangle add to be 180. So I'm going to take 4x plus 10 and add that to 6x minus 3 and add that to 2x plus 5. And that equals 180 degrees. So then we'll solve this. Combine like terms, subtract 12 from both sides. So 12x equals 168, and then divide by 12 and we get x equal to 14. Put 14 into each of these, you get 4 times 14 plus 10. 6 times 14 minus 3. And then 2 times 14 minus 5 plus 5. So we get 66, 81, and 33. And I always like to do a check to say, okay, let me add these 3 angles together and make sure they add to be 180, and they do. So then I want to order. So we're going to go least to greatest, right? So we're going to figure out which of these sides is the smallest. Well, here's the smallest angle, so this is the smallest. This is the biggest angle, so that's the biggest. And then BC is the middle, so it will be AB to BC to AC, and don't forget your lines over the top of those letters. Okay, last part of this is to figure out which one of these is the longest, well, close to the last part, the longest side of this figure. So these start with one triangle at a time. So the first triangle, the one on the left, I've got the longest side on this one. If we order these, it goes 50, then 60, then 70. So 50 is across from WK. So for this one, WK is the smallest. And that one is less than DK. And that one is less than, across from 70 is the DW. Okay, then we'll do the same thing for the other one. The smallest side on this one is DN. And that is smaller than NK. And the biggest side in this triangle is DK. So we're asked to figure out what the biggest side is, the longest one is. So let's kind of lay these outside or above and below each of them so we can see what's going on here. I've got NK and then DK for the one on the right. And then the one on the left, I've got WK, DK, and then DW. So DK is the same in both of these, right? Well, DK is bigger than this one, bigger than that one, it's bigger than that. So DK is also bigger than this one. The only one it's not bigger than is DW. So DW is the longest side in this figure. So don't be fooled by these. It kind of looks like DK might be, but this one right here is, because you have to set up the inequalities to go with the longest sides. The last theorem of this lesson is the triangle inequality theorem. The sum of any two sides in a triangle has to be bigger than the other. So this side plus that side has to be bigger than this side. Same thing for any other two sides. So we're going to check to see if we can form a triangle with sides of these lengths. If that's true that any two sides have to be bigger than the third, these two added together make 13, and then this is 14 1/2. If this is a triangle, this should be greater than 14 1/2, the third side. So this is false. So no, it won't make a triangle, because the sum of the other two sides is not bigger than the third. So we're going to try to find a length of the range of values for these. We're going to go and label this. This is XY is 6, YZ is 9. We don't know what this one is. So I'm going to set up these ratios here, and then I'll be back. I set up the inequalities. Now I'm going to solve each of these. I'm going to take away 6 from both sides on this one and get XZ is greater than 3. Oh. And then if I take away 9 from both sides, I get XZ is greater than -3, because I take away 9 from both sides. This video is about to run out of time. I don't have the extension on this, so I'm going to make a second video with the last slide and the answer to this on it. So come back for that.